Hello student, today I am going to discuss about the space in linear algebra special matrix. First I discuss the singular matrix. Those matrix is called singular matrix if the determinant is 0. Okay, let A be a matrix is said to be singular if determinant of A should be equal to 0. Okay, so the for case of non-singular, if determinant is not equal to 0, then those matrix is called non-singular. Okay, take a example. Okay, now take the determinant of A, it should be 0, so this A is singular matrix. Let's take another example. For example, 2 0 0 1. What is the determinant of that A? This should be 1 and this is not equal to 0, so this is a singular matrix, singular, and this is non-singular. Okay, next, symmetric and skew symmetric matrix. A matrix is said to be symmetric if the transpose of A is should be equal to A. This is called symmetric. And for the case of skew symmetric, if transpose of A equal to negative of A, then this is skew symmetric. Okay, let's take an example. And the transpose of A should be same 1 0. You write each row to each column, sorry, each column to each row, each column to each row, so this is should equal to A, so this is a symmetric matrix. And now the example of skew symmetric matrix. This is symmetric matrix, this A, and okay, the transpose of A 0 minus 2. Okay, yes. Okay, take a negative common from this matrix. What will be the value? 0, 2 here, negative 2 here, 0. Okay, observe that this is equal to A, negative A, so this matrix is called skew symmetric matrix. Okay, so these two properties for symmetric matrix and skew symmetric matrix. Okay, now the Hermitian matrix and skew Hermitian matrix definition. For the case of Hermitian matrix, if a matrix is said to be Hermitian if the transpose of A and its conjugate with equal to A. Okay, secondly, skew Hermitian. Similar for symmetric and skew symmetric matrix, only difference is conjugate here. Okay, that should be the transpose of a matrix with conjugate should be equal to negative of A. Okay, let's take an example. One thing, that the Hermitian each matrix, the element of Hermitian matrix each complex number. Okay, so let's take an example A. I don't one things, let complex number A plus IB. Okay, this is the format of complex number. The conjugate, that means conjugate of that complex number should be a minus ib, and it is denoted as, okay. So here it is the a matrix. I take this matrix. The transpose of this matrix should be, make each column to each row, make each column to each row, each column to each row, 5. Okay, then conjugate each element of that matrix. Since 8 is only real number, so the conjugate of real number should be equal to that real number. For the case of complex number, the sign will be changed from the iota, from iota side, I minus I. Okay, for this case I plus I, and this is real number, will be same remaining. And observe that this is equal to a. This is the example of symmetry, sorry, Hermitian matrix. And the skew Hermitian matrix, I take an example. And take the transpose of a. What will be the value? 5i minus 3 minus 2i, 3 minus 2i, 5i. Okay, and take the conjugate of that. Okay, I write here transpose and its conjugate. Okay, so I already told you that add negative with before iota, so this should be minus negative I, minus 3 plus 2i, 3 plus 2i, sign will be changes, that's all, minus 5i. Okay, then after that I write here, from here to here, take a common of negative. What will be the value? 5i. This negative will after common a negative value from this complex number, so this should be 3 minus 2i. Okay, and from here minus 3 minus 2i, and here 5i remaining. So observe that minus 1, it is equal to the given matrix A. So this matrix is example of skew Hermitian matrix. Now, okay, the definition of unitary matrix. A matrix U is said to be unitary if its inverse, U inverse, we know the inverse of a matrix, is equal to conjugate transpose. That means here U inverse equal to conjugate transpose. This is the denotation of conjugate transpose. Okay, then that matrix is called unitary matrix. So what is the property of inverse? U inverse equal to U. For example, let us assume the denotation of conjugate transpose is U star. Okay, U inverse U equal to I. This is the property of inverse. Okay, now since U star is equal to U inverse, so we can write U star here, U star U equal to identity matrix. Okay, now let's take an example. Okay, A equal to half of okay, now we want to find the first transpose. Okay, this is the transpose of A, and now take conjugate of each element of matrix. Just change the sign of each entry. Okay, now we want to show that the given matrix is unitary. That means A I write here for uh, short form. A star should be equal to 1. That means identity matrix. Okay. Okay. Just remove this term 1 by 4 here, and row wise, column wise. This is the formula of like that, a plus b into a minus b. We know that a square minus b square. Okay. And another thing is iota square is minus 1. Okay. So observe that a plus b, a minus b, so that should be 1 square minus iota square. We know that iota square is negative 1, so 1 plus 1. Okay. Similarly for this one, 1 plus I whole square, 1 plus I whole square plus 1 minus I whole square. What is the formula for this? Okay. One things, I may be wrong with. Okay, I've maybe I wrong. I forgot it. There is another 1 plus 1. Okay, because of this multiply this with this multiply this, so this is 1 plus 1 and this is also 1 plus 1. Okay. Similarly for the second entry should be 1 plus I whole square plus 1 minus I whole square. And what is the formula for a plus b whole square plus a minus b whole square? This is equal to 2a square plus b square. We know that also. And here observe that this should be, okay, this is also same as here, and this is same as here. And I write the total calculation here. It comes 4, 1 by 4. This is 4 and this is 2a square plus b square means 2 1 square plus iota square, that means it should be 0. And this also 0 4. If we common a 4 from the matrix, then that should be identity matrix. Similar way you can verify that a star a should be iota. Okay, so that matrix is called unitary matrix. Let's start with definition of orthogonal matrix. A matrix A is said to be orthogonal if A transpose should be identity. Okay, let's take example. What will be the transpose of A? Now start with A transpose. You can observe that here it is 1, here it is 0, here it is 0, here it is 1. This is identity matrix. So A matrix is orthogonal matrix. Okay. A matrix is said to be idempotent if A square should be equal to A. Okay, let's take an example. Let's take 1 0 0 0. Okay, now what is the square of A? Okay, if you multiply those two matrices, it should be also. So A is the example of idempotent matrix. The definition of idempotent matrix is that should be the satisfy this equation, a square equal to a. Okay, now a matrix is said to be involuntary matrix if it satisfies the property which is a square should be identity matrix. Let example 4 minus 1 15 minus 4. Okay, a square 4 minus 1 15 minus 4 multiply with same 4 are 16 minus 15, this should be 1. 4 minus 4 plus 4, this should be 0. Okay, observe that 15 4 are 60, 60 minus 60, it should be 0. Minus 15 plus 16, this should be 1. Okay, this is the example of involuntary matrix. A matrix is said to be nilpotent. Let A n cross n matrix, okay, is said to be nilpotent. What is the condition? If a to the power k should be 0. Okay, it is the power of k where k is less than equal to n, that means it is equal or less of n. Okay, now take a example. A is equal to 2 minus 1 4 minus 2. That means we want to find what is the power of k. What is the power of k? I put then a to the power that power should be 0. Now find first a square 2 minus 1 4 minus 2. This 2 was 4 as 0. Okay, it is minus 2 also 0. 8 0 minus 4 plus 4, it should be 0. Okay, so here the values of k is equal to 2. Okay, you can get a matrix such that the k's value is 3 4, but one thing, that k should be must be less than equal to n. Okay, when we take we take the 2 cross 2 matrix, so the maximum value k should be 2. Okay, when you get a 4 cross 4 matrix, okay, observe that we take a 0 matrix 0 0 0 0. Okay, it is 2 cross 2, but one thing, the power of this is a, the power of 1, we already get a 0 matrix, that means here k equal to 1, so k must be less than equal to n. That means ends here the order of matrix. Okay, here it is the example of nilpotent matrix and definition of nilpotent matrix. Okay,